What's up, math fans? This is a brand new idea, so I'm not going to do too much math. I'm just going to explain graphs for you. And it will lead into how to find roots and how to relate the roots to an actual equation. But right now, I'm going to talk about classifying polynomial functions. And a function is a relationship between x and y. So you can think of a function as a graph. You can think of a function as an equation. Here's an example of a function that you already have been dealing with. Y equals x squared, right? That's a function. And since I'm using the word function, I might replace the y with f of x equals x squared, all right? So these are examples of functions. This is more function notation. F of x, meaning a function of x equals x squared. So depending on whatever x is, f of x depends on that. So just like y would depend on x, f of x depends on x. It's the same thing. It's just a notation. So first, in order to understand what you're looking at, I want to talk about all these different graphs. And if you remember, this is a basic review graph. You knew this from Algebra 1. This is a line. This is a linear function. This one is a parabola. It's a quadratic function. All right? So when you're dealing with a linear function, think about what the equation was. You remember this equation? Y equals mx plus b. That's a line. All right? Now, what is the highest power of x? The highest power of x, meaning what's the exponent there? There is none. That means there's a 1, a hidden 1. You should have known that already. So the degree, instead of using the word power, we're going to use the word degree. So the degree of this is 1, and 1 is an odd number, so this counts as an odd degree function. Now you remember this one, quadratic function. What does that look like? Y equals ax squared plus bx plus c. What's the highest exponent here, or the highest degree here? It's a 2, so what's the degree? It's an even degree because 2 is an even number. Now, if you understood these two, you can understand any degree. So if I gave you something like y equals x to the third, that's a third degree, but guess what? 3 is an odd number, and it behaves the same as this one, and I'll explain what I mean by how it behaves in a second. What if I went here and wrote y equals x to the fourth plus x to the third plus x squared plus 5x plus or minus 9? That's some crazy function, right? But what I'm worried about is the highest degree. That's how you classify a polynomial function. You just worry about the highest degree. Here's my highest degree, because I gave it to you in descending order. My highest degree came first, and it's x to the fourth. 4 is my highest degree. So if that is my highest degree, it's known as a fourth degree function, and 4 is an even number, so that's an even degree function. All right. The next one obviously would be y equals x to the sixth, or you know what? What did I say a minute ago? My notation can change, so I can even write f of x equals x to the sixth. So this would be a sixth degree function, also an even degree. What would this one be? Y equals x to the fifth, that's a fifth degree, etc., etc. If the highest degree is odd, it's an odd. If the highest degree is even, it's an even. Simple as that. But how do odd and even functions behave? So here's what I mean by behavior. Let's look over here. You notice I only have the x-axis. I just want you to be able to visualize something. And then I also have only the y-axis here. I just want you to visualize something. So graphs look like this, right? They have x and they have y. So all I did was I took this graph and I redrew it only on the x-axis, because some people have a hard time conceptualizing this. You get the notation looking like this. What does that mean? If you read it out loud, this says, as x approaches, arrow means approaches, as x approaches infinity, what is happening to y? What is y approaching? So you go along your x-axis, you pretend you're actually there. This is you running on the x-axis. So as you run along the x-axis towards infinity, and positive infinity is this way, what is happening to the y? So here's your friend along the y-axis, and your friend is running along the graph. What is happening to the graph as you go this way? So that means you're following the graph going in this direction. So this is you running along the graph. And as you run that way, the graph starts to shoot up. So if you follow the numbers on the y-axis to match where the graph is going up, meaning y approaches positive infinity also. This is what I mean by end behavior. what's happening at the end of the graph. As x approaches infinity, y approaches infinity. What if I was going backwards? What if you started to run that way on the x-axis? So as x approaches negative infinity, what would your friend be doing if they were running backwards on the graph? Towards the left is what I mean by backwards. So as you're going left, your friend is running along the graph and they end up going down. So as x approaches negative infinity, y also approaches negative infinity. All right? So that's what I mean by end behavior. As the graph grows, the graph grows. As you go backwards, the graph declines. So the beginning of the graph came from down here. The end of the graph goes up there, and it's kind of like this. You can do the little graph dance. This is an odd degree function. Always looks like this. Notice your very first odd degree function that you've been doing for years also looked like this, from down to up. So this one, down to up, just with a twist. Guess what x to the third is going to look like? Type it in the calculator. It's going to go from down to up. Actually, this is x to the third with some twist in it. It's not just x to the third, but this is my highest power. Guess what x to the fifth would look like? Also something from down to up. Maybe with some wiggles in the middle. But I'm just talking about the ends right now. I'm not telling you what's in the middle. All right? What about even? Your favorite x squared was up and back up. Guess what x to the fourth would look like? Up and back up. X to the sixth. Any even would all be up and back up. All right? So that's how you can classify if you're looking at an odd or an even. Odd would look like this. Even would look like this. Simple as that. All right? Now, there's other things you should be looking for besides end behavior. How many times is it across the x-axis? That's how many roots you have. Roots are also known as zeros, also known as solutions. Roots, zeros, solutions. How many? 1, 2, 3. And what's cool is if you have a graph, you can see the actual solutions. You would know what the answers are. -1 and -4. That's 2 solutions right there. And +2 is a third solution. 3 solutions means it was a cubic. Okay? And guess what else? You can count the turning points. Graph is going up, 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 turns, goes down, 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 turns, goes back up. 2 turning points. There's a relation with all of that stuff. So check this out. If you're looking at whatever the degree is, let's say the degree is n, then the solutions should match it. You can expect as much as or up to n solutions, a maximum of n solutions. Sometimes you will get less solutions because they might lift up the graph. It is possible to have a graph above the x-axis and then you only have imaginary solutions and it's much harder to see, but we're worried about just the max right now. So if I have an n degree, meaning if I was looking at something like y equals x to the third, my degree is 3, my solutions will match that. I will expect 3 solutions or up to 3 solutions. And how many turning points would you expect? That's right, 1 less than that. You'd have 2 turning points, n minus 1, 2 turning points. It has to turn 1 less time to have those many solutions. All right, so here's a basic question you might see on a test. Looking at this graph and they're asking you what would be the degree of this graph here. So I gave you some samples of just the first term. What could possibly be the first term of this graph here? So first of all, I'm looking at the end behavior and they're both down. But Professor Noy, you only gave me down, up, and up, up. How could they both be down? Well, here's your clue. They're going in the same direction. So this is an upside down version of an up, up. So you definitely can conclude it's even. When the end behavior is in the same direction as even, whether it's up, up, or down, down. Next. So that's eliminated, and that's eliminated. They're both even. I'm sorry. This is eliminated, and this one is eliminated. Sorry, this one is not eliminated. Negative x to the fourth. So it's either this one or this one. Now, if it was positive coefficient, you're coming from up and up. If it's negative coefficient, it flips the whole graph down and down. So here is your answer. Try to remember that. Negative coefficients flip the graph. And that's basically it. You're just looking at behavior, and that summarizes the behavior. Thanks for watching. See ya.